All right, this is day 3 of transformations. Today we're going to talk about rotations, which are essentially turning a graph. So the direction of rotations can be either clockwise or counterclockwise. And that just means the way the clock goes. So a clock goes in that direction from noon, 1, 2, 3, and then counterclockwise would be going the other way. So those are the two directions that you can rotate things. And every rotation has an angle of rotation. So how much are you rotating? If you think about any of the Olympic sports, skiing, snowboarding, they have so many degrees of rotation that they are spinning around. Or yeah, how they're spinning around. I don't know where I was going with that. Or how much rotation image has moved from the original. So just how much have you turned? When you're performing a rotation, the distance from the origin stays the same. So if you were 1 box away from the origin, you have to stay 1 box away when you rotate. You can't magically end up way far away. So we're going to graph JK and LM for each one, and we're going to decide if LM is actually a rotation of JK. So first I'm going to draw JK. So J is a 3, 1 right there. K is 1, 4 right there. Oh, and I drew an F. That's okay. And now we're going to draw L, which is -1, 3. And M, which is -4, 1. And that's their segment. So now the question is, are these rotations of each other? So first we have to have an angle of rotation, and we have to know what direction we're rotating in. So now they asked me if LM is a rotation of J, so that means that L is going with J and M is going with K. So from L to J, we need to see if that's a rotation. So I'm going to just take J and I'm going to go into the center, and then I'm going to go back out to L. And what I'm trying to do is first see if they are the same length. So it looks like I went over 3 and then up 1 to get to J. And for L, I went back 1 and up 3. So since my left and right and then my up and down moves are the flips of each other, that distance is going to be the same. If I did Pythagorean's theorem on that little triangle, the dotted lines would be the same. I'm also noticing that these guys look pretty much like a 90-degree turn. And although you can do any degree of turn, we're going to mainly stick to like 90, 180, and 270, as you can see coming up down here. So that looks like a 90. I'm going to grab another color, and we're going to compare that to M and K and see if they are the same thing. So I'm going to draw K into the center. I'm going to draw K back out to M. First, I'm going to check to see if they're the same length. So if I were to look at this triangle that I kind of make right here, I'd have a 1 and then a 4. And then this triangle would have a 4 and then a 1. So they would end up giving me the same thing in Pythagorean's theorem. So they're the same length, same distance. And then if I look real close at just the pink, that also looks like a 90-degree angle. So I would say, yes, this is a rotation. And I would say 90 degrees, and we were going from JK to LM because we were asking, is LM a rotation of JK? So from here to here, and since we're traveling in that direction, we would be counterclockwise. That's not how you spell that. Okay. When you come back to class, what you're also going to get is a Post-it note, and this one is going to be see-through, which is kind of interesting. So here, I'm just laying my see-through Post-it note on top of my graph. I'm just going to trace KJ with my pencil, and then I'm going to hold my pencil at the origin to hold my Post-it note still. You're going to have to, actually the smarter move would have been to do that upside down so that my paper doesn't keep sticking. But here, we're going to attempt to see if this is a rotation. Sorry, one more thing. Put a little notch where the axis is so you can tell when it has turned. So I'm going to hold my pencil still. I'm going to hold my little Post-it note down right there, and I'm going to turn until my axis ends up at the Y. So I'm turning 90 degrees, going from that little tick mark to up on the Y-axis. And what do you know? My segment landed right on top of LM. So for sure it is a rotation 90 degrees counterclockwise. Let's do the next one. So I've got J and K again. J is at -2, 1. K is at -1, 5. 1, 2, 3, 4, 5. There's K. L is at 1, 1. And M is at 2, 5. And so now we are trying to decide if these two are rotations of each other. So we're going to first do our length check. We're going to make sure that they were the same distance from the origin. again, we're trying to see if LM is rotation of JK. So that means that J and L go together. So I'm going to draw into J, out to L, and right there I'm in some trouble. From J I had a 1 and then a 2, and to L I just have a 1 and a 1. So they are not the same distance. They kind of look like they could be a 90-degree angle though. So let's check K and M. Taking K into the middle and M into the middle, you might be able to convince yourself that they're the same length, but this one only goes 1 and then 5. This one goes 2 and then 5, so they'll be different lengths. And then that angle in between the pink lines does not match the angle in between the blue. So this for sure is not a rotation. We would actually call this one a translation. This is just a slide, and we're moving back and forth. And just to reiterate it, here I am. I'm going to use the exact, I can't use the same picture. You silly goose. Okay. I am going to turn it over so I can stop doing that. So there's my dot for the center. Here's my mark for where my axis is. JK was my line, and I'm just going to hold it down and attempt to rotate. And no way when I rotate do I end up on top of ML. So this is not a rotation. This is a translation. There are 3 different rotations that we do, and they come with some rules. This would probably be the part that you'd want to make sure you know for the test. So a 90-degree clockwise would look like this. So 90 degrees clockwise. It is the same as, it's also known as, a 270 counterclockwise. So going that way 90 is the same as, I'll pull my marker, is the same as going 270 the other way. So they land in the same, oh boy, I just did that. Oh, forgive me. I was looking at those arrows. It would be going this way. And I just uncovered it again. Hold up. It's not my first rodeo. Okay, be careful. All right, so this would be counterclockwise, that is clockwise. And the rule for that, or what you do to all of your X's and Y's that we've done before, we're going to actually switch X and Y's place. So we're going to swap where they are, and you're going to switch the sign on the X. So that means, right there means switch the sign. If it was positive, it will be negative. If it was negative, it will be positive. The 180 clockwise, so that would go like this, is the same as a 180 counterclockwise. So they go the same distance, 180, and they meet in the same place. So this would be the same as 180 counterclockwise. Its rule, since you want to end up in the exact opposite place, is you would just opposite your X and opposite your Y. So we would switch both signs. Last one is a 270 degree clockwise, which would be like this. And that would be the same as a 90 degree counterclockwise. So kind of like the opposite of the 90 down here to 270. So when we go to write our rule, yeah, we will do that too. We'll still switch the X and the Y, but this time the Y will get its sign switched instead of X. And on the test, you'll be able to use your see-through Post-it note. So make sure you keep that handy so that you can use that on the test. Or if you need a new one ever, just let me know in class. You can pick up another one. I got a whole stack of them. I'm going to use my Post-it note as we do this next one, and I'm going to write you the rules. So we're going to do a lot of pieces here. So using these vertices, complete a 90 degree clockwise and a 180 degree rotation. So A is at 1, 0, that's right here. B is at 2, 3, that's right there. And C is at 4, 1, that's right here. So we're just looking at a simple triangle, and we're going to rotate that 90 clockwise and 180. So first we're going to do the 90 degree clockwise, which means we're going to take each of our X's and Y's, and we are going to flip them and make the X opposite. So I'm going to take my A, which is 1, 0. I'm going to flip it, and I'm going to make my X opposite. I'm going to take my B, which is 2, 3. I'm going to flip it, and I'm going to make my x opposite. I'm going to take my 4, 1, I'm going to flip it, and I'm going to make my x opposite. So this would be my new A, my new B, and my new C. So my new A is going to be 0, negative 1. My new B is going to be 3, negative 2. And my new C is going to be 1, negative 4. Oops, missed it. All right, there's my picture. I'm going to double check it with my Post-it note. So I'm going to make a little axis there and a little tick mark so I remember where I'm turning. Here's my triangle. So I'm going to hold that still, and I'm going to rotate 90 degrees and just make sure that everything lands on top of the points that I made. So it's kind of neat using these see-through Post-it notes because they help you see how stuff turns. So all I did was hold it still at the origin, and I just turned enough until that mark that I had made turned to the next axis. So I just turned, get my pencil out of the way here, until that mark came down here, and I lined right up my triangle. The pencil one is right over the one that I drew. We got one more to go, and that's your 180. And it doesn't matter if you consider it to be clockwise or counterclockwise, the rule is the same. So we're going to take our x's and y's and we're going to flip them both. I'm sorry, keep them both the same, but we're flipping the sign is what I should say. So this is going to be negative 1 and then 0. Can't really flip the sign on 0, so don't worry about that. This will be negative 2, negative 3, and this will be switching both signs, will be negative 4, negative 1. This is my second A that I'm drawing, so it's getting 2 tick marks along with my second B and my second C. Since I'm doing another transformation, we're going to give them slightly different markings so I can tell them all apart. So my A is at negative 1, 0 right there. I'm going to put 2 tick marks on that. B is at negative 2, negative 3. Again, 2 marks. And C is at negative 4, negative 1. Connect. Looking good. I'm going to use my Post-it note again. See if I can get it to line up. There we go. And we are going to spin at 180 degrees. So that mark has to end up over there. A full 180. So here we go. Turning it, and I end up right on where we had drawn it underneath. We got one more. It says, can you tell if this is a rotation? If there's a rotation, give the angle and direction of the rotation. So they are asking me if ABC is a rotation of EDC. So that means that A goes with E. So I'm going to just dot A into the origin and then out to E. That looks like a pretty good rotation. It doesn't look quite like a 90 when you turn your head. Looks like less than that. Next up, B goes with D. So if I draw in from B to the origin and then out to D, those two do not match. For sure, I know that one is 180 degrees that we just did. That one is not. So this is not a rotation. Not a rotation. That is a reflection. I turned one shape over the y-axis into the other. So that's rotations, definitely out of the 3, out of the 4 we end up doing. This one's usually the toughest for kids. Make sure you spend a lot of time looking at this chart so you know all the rules for each of those moves.